In this lesson, we're going to be looking at solving quadratic equations in the form of y equals ax squared plus c. Okay, so you notice that the bx in the middle is not there this time. Okay, so before we start, I just want to review a little bit about how to find the x and y intercepts from linear equations. Okay, so remember that when we want to find the x-intercept, we put y equal to 0. And when we want to find the y-intercept, we set x equal to 0. Okay, so let's do the first one. So we're first finding x-intercept, so that means that we're going to put in 0 for y. Okay, 2 times 0 is 0, so I just have 3x is equal to 6. Divide by 3, so here x is going to be 2. Okay, so writing it as a coordinate, the intercept is at 2, 0. Okay, so I have my x-intercept, and then my y-intercept, I'm going to put x equal to 0. Okay, this becomes 0. And 2y is equal to 6. Divide by 2. So y is equal to 3 here. Okay, so x was 0, and y was 3. Okay, so now we have both of our intercepts, and I can graph them 2, 0, which is right here, and 0, 3, and we would connect them to make the linear equation. Okay, so just a little bit of review because that's what we're going to be talking about with quadratics. Okay, so when we solve a quadratic equation, we use the same technique. We're going to substitute 0 in for y to get x, okay, because we want to find the x-intercepts, okay? In this case, there are going to be 2 of them, okay? So I'm going to substitute in 0 for y. Okay, so this is going to become 0. So over here, I have x squared minus 4 is equal to y. Substitute 0 in for y. Okay, next step would be to solve for x, so I'm going to add 4 to both sides. Add 4 to both sides. So now I have x squared is equal to 4. Okay, so when I have something that is squared, to undo the square, I need to take the square root. So I'm going to take the square root of both sides. Square root, both sides. If I take the square root of x squared and the square root of 4, I now have x is equal, the square root of 4 is 2, okay? But it could be positive 2 or negative 2, okay? Remember, because positive 2 times positive 2 is 4, and negative 2 times negative 2 is also equal to 4, okay? So the intercepts then here, x could be 2 when y was 0, or, and x is also negative 2 when y is 0. So I'm going to graph both of these points on my graph. So 2, 0, and negative 2, 0. Okay? So I also know that the c value, x squared minus 4, is equal to 0. Okay? So this minus 4 is my y-intercept. So I need to go down to negative 4 on the y. Okay, so this is my vertex point. And now I know that I can go through my roots to create my graph. Okay, so in this case, we have 2 roots. Okay, so what did we notice about the solutions to the x and the x-intercepts? That they are, in fact, 2, 0, and negative 2, 0. Okay, there are 2. So for this reason, the x-intercepts are also called the zeros. Okay, because we're plugging in 0 for y to figure it out. Okay, so if you're asked to find the x-intercept, another word that you need to be familiar with is the word find the zeros. Sorry guys, not zeros, they're called roots. I'm sorry, I mixed it up. Okay, so the solutions are the x-intercepts, and then another word that we call them is called the roots. Okay, sorry about that, you can scratch that off. Okay, all right, so let's try a couple problems to check our understanding. Okay, so we want to try and solve these equations. There might be no solution, and we'll go over that if we come across it as well. Okay, so it looks like we've already set the equations equal to 0. Okay, so we already substituted in 0 for y, which is right here, because these should all be y equals, and they all say 0. Okay, now I'm going to solve for t squared. So add 25 to both sides. Cancels out. So t squared is equal to 25. Then I need to take the square root of t squared and also 25. Whatever I do to one side, I do to the other, is equal to positive 5 or negative 5. So I'm writing it as plus or minus 5. Okay? Because we substituted in y for 0, we have x is 5, y is 0, and we have x is negative 5, y is 0. Okay, so again, these are the two x-intercepts, which are also called the root. All right, so I'd like you to pause the video for a moment and try the next two on your own, B and C. Okay, so let's see how you did. Okay, so again here, we already put y is equal to 0, so now I'm going to solve for n squared. So 3n squared is equal to 12. Okay, here I have another step. I need to divide by 3 first to get n squared by itself. Now n squared is 4. If I take the square root of both sides, I get n is equal to, the square root of 4 is plus or minus 2, because it could be positive or negative 2. Writing it as the root points, I have 2, 0, and negative 2, 0. Okay, I'll change my colors here. All right, and then the last one. Again, solving for g squared. I have 2g squared is equal to negative 32. Divide by 2, and g squared is equal to negative 16. Okay, so if we look at this one, we kind of run into a problem. See if you guys figured it out. If I take the square root of g squared, I get g. Okay, but if I take the square root of negative 16, I can't do that because we can't have a negative underneath the square root sign. So in this case, g, we have no solution. Okay, so here for parts D through H, we're going to work on these in class, and then we'll check over them in class. So I'm going to move down to example number 2. Okay, so let's try solving a couple that are not perfect squares, okay? So we're going to do the same idea, okay? So for number 1 here, I'm going to add 100 to both sides. Add 100. Okay, because I want to get x squared alone. So I have 2x squared is equal to, this cancels out, 100. Okay, then still solving for x squared, divide by 2 on both sides. So divide by 2, and I have x squared is equal to 50. Okay, so now I want to take the square root of both sides. Square root. Okay, so the square root of x squared is x. And here's where I run into the problem because I can't take the square root of 50, okay? But I can think about, well, what multiplies to 50 that one of them is a perfect square, okay? So if I do 25 times 2, that gives me 50, okay? 25 is a perfect square, so what I can do is I can multiply these together. The square root of 25 times the square root of 2 is the same exact thing as the square root of 50, okay? So now I have square root of 25, which is 5. And then I'm just going to have to leave it as square root of 2 because this is not a perfect square. Okay? So x is actually equal to, and remember for 5 it could be positive or negative. So plus or minus plus or minus 5 square root of 2. Okay? These are multiplied together. So x is equal to plus or minus 5 times the square root of 2. If you wanted to write this as the points for the x-intercept, you would have negative 5 square root of 2 and 0. And then the other one would be 5 square root of 2 and 0. Okay, so the two answers. Okay, so going forward, you can just leave your answers in the form right here where it's just x is equal to what they both are. Okay, so I'd like you to try to check your understanding for the 3 below and then check back over your work. Okay, let's see how you did. Up here I actually forgot to put simplify the square root. We did that. Okay, so solving for a, we want to get x squared alone. So I have negative 5x squared is equal to negative 100. Divide both sides by negative 5. X squared is equal to 20. Okay, now we need to take the square root of both. Okay, I can't take the square root of 20, so I need to try and simplify it. Okay, so I want to think of two numbers that multiply together, that one of them is, in fact, a perfect square. Okay, so here I can do square root of 4 times square root of 5, because 4 times 5 is 20, and then I can do square root of 4, which is 2. Okay, so square root of 4 becomes plus or minus 2, and then square root of 5 stays the same because I can't take the square root. And your final answer is x is plus or minus the square root of 2. All right, moving on to the next one. Solving for x squared. Divide by 3. And now we want to take the square root of both of these. Okay, so x is equal to, let's see if I can simplify 6. The only thing that multiplies would be 6 times 1, and that won't help me, or 2 times 3. 2 and 3 are not perfect squares. So in this case, this is the simplest form it can go. So my answer is just going to be plus or minus the square root of 6. Okay, because remember that once we take the square root, it could be negative. All right, and moving on to the last one. Solving for x squared. 2x squared is equal to 66. Divide by 2. X squared is equal to 33. Okay, if I take the square root of both of these, I have x. And now I need to try and simplify 33. So what numbers multiply to 33? Well, the only ones I can really think of are 11 times 3. And neither of these are perfect squares, so I can't break it apart. So my final answer is just going to be plus or minus the square root of 33. Okay? You don't need to actually type this in your calculator and get out the decimal. This answer right here is the final form. Okay, so in this lesson we kind of talked about how to solve quadratic equations in the form of y equals ax squared plus c. Okay, so next class we're going to add in the middle term, the bx. Okay?